Good morning, everybody. My name is Jack Dangermond, and I want to, on behalf of all of my colleagues here at Esri, welcome you to the Fed 2021 conference. Also welcome you to Redlands virtually. It's nice and warm here, unlike our normal experience of the Fed GIS conference, cold and freezing inside of the convention center in downtown DC. But anyway, it's a great pleasure to welcome you. This is an important few days. It'll be important for us to share and tell you what we're doing. The purpose is always to connect people, to have them share and learn and create a better understanding within our little community. And you are a very interesting audience for me, special, I would say. You're a community of GIS professionals working across the different agencies in the federal government. You have mission work, you have different disciplines, you have different backgrounds in different geographies. And the mission of this year's conference is about interconnecting our national government using GIS and geography. I'll come back to that theme again and again. But I'd like to always start this meeting with a little bit of sharing of your work. This is important work. I mean, it's some of the most important work underway in our country and in the world. You're working on basically all the big issues in natural resources, from climate change to looking at social conflicts and urbanization and development, water resources, all of this. And over the last couple of weeks, I've been looking at examples that you shared with me about your work. Every one of them is an amazing little story. It's an icon of what it means to be a GIS professional working in public service. Some of you are working on some of the big issues of environmental monitoring and modeling and assessment. These examples make it clear that we are measuring environmental change, looking at everything from countrywide air pollution to local pollution. This map done by Harvard University on environmental justice and racial equality shows the impact, the disproportionate impact of air pollution on blacks in the South. Last year, we had massive wildfires here in the West, and the map that's brilliant red there on the right is showing the impact of ozone moving across the United States. Actually, more ozone was emitted in those couple of months of wildfires, burning 4 million acres of forest here in our country, than all of the air pollution contaminants emitted by all the vehicles for many years across the United States. Look at the interesting work going on delivering measurements like air quality and weather to citizens on devices. And then there's this beautiful map that's in the lower right showing airflow modeling at a micro level. Lots of work going on here. In the world of natural resources, we're seeing climate's impact creating change dramatically, like forest change or land cover change or the effect of drought. The map in the upper left is showing the effect of climate change on specific lakes in Iraq. And I'll just finish by pointing out this one that shows coral and habitat modeling. The changes in the oceans are really dramatic. Your work in natural resource management is outstanding. You're looking at agricultural change and managing it more effectively, looking at agricultural suitability assessments across, for example, all of Mexico. And in the upper right, looking at forecasting winter wheat across Asia, very important for our own economic health here in the United States. In the field of transportation, GIS has long distinguished the ability to manage and do analytics on transportation systems. And these maps are pretty amazing. The ones in the lower left show RF and ship tracking from traditional means from AIS. And look at the interesting work going on in Maryland, showing in real time all operations on all highways. And then there's using AI and machine learning to do and assess various environmental characteristics that are impacting accidents in Indonesia. And one of my favorites here is the drone delivery routing. This is using like air corridors to optimize routing for product delivery across the countryside. These are new maps for me. they're looking at financial as well as public infrastructure oversight. You're looking at where the money goes and what its effect is, and being able to target where the money should go, things like business loan and grant targeting and economic development. And, well, there's this major issue of the digital divide that people talk about, and this has to do with broadband coverage for real. Your work in those areas is amazing because it's illuminating where we have gaps. And then there's the more traditional energy and telecom coverage, wind generation, infrastructure across the nation, which does require oversight and understanding for us to make our country better. GIS has been moving recently into the field of buildings and facilities, modeling complete buildings with BIM models and then bringing them into GIS. But these examples go much further than that. They're looking at space planning, space management, and look at the beautiful, interesting maps on the lower right showing work order management within government housing in New York City. I think we're going to see a revolution in the ability to utilize buildings more effectively using GIS as a framework and as a background. Our world, our nation, our country, our cities, our regions are becoming safer because GIS is impacting from a holistic perspective, giving us insight into problem areas. These maps show things like crime density and patterns, doing hotspot analysis. Some of them are showing in the lower left, for example, conflict assessments for the entire continent of Africa. And then there's looking at managing statewide emergency management issues. GIS has long distinguished itself, or you have distinguished GIS, I would say, in the area of disaster preparation and response. These examples show everything from debris recovery to fire change to hurricane impacts to hurricane awareness and flooding. All of these things, organizations like FEMA and individual agencies are working on systematically using geography as a foundation. In the last few decades, remote sensing, imagery, LiDAR in more recent times have become a major part of GIS. And these examples show your work in everything from simple vegetation mapping to looking at building change analysis in geographies and cities. We're seeing from satellites the ability to track vessel movements and discrepancy between AIS feeds and RF feeds. These are interesting issues that the remote sensing gives us that we've not been able to see in the past. Mapping and cartography are just the language of GIS, we might say. And these examples show us some real interesting work. You're making, for example, beautiful forest maps so that people, visitors, can have access to and visualize forests in new ways. Other examples show us the mysteries of coral reefs around the world, the good work from Conservation International. And USGS, through their 3-depth program, is not only allowing us to see and analyze more effectively terrain, but also providing beautiful backdrops, for example, this soil and ecological mapping thematic map. Portals, one of my favorite subjects, enabling open data and citizen engagement, allows us to make our data available. And these are a few of the examples. Crowdsourcing information, getting data in, for example, the mapping of trees or doing citizen science, but also the ability to provide open data to organizations, community portals, the education statistics, the data hub, for example, for COVID, done by HHS. These are amazing contributions. And then what I'm seeing systematically is more of you are building interactive applications so that people in a browser can do, for example, watershed analysis, or they can do their own discovery of the best location to register their votes. And again, I'll draw your attention to one of my favorites, which is the spatial bibliography that was done by NOAA. It's really opened up all the publications around Alaska and allowed people to browse and look and examine this information. Demographics, social equity, and public health are major issues that people care a lot about, especially in the last couple of years. The Census Bureau, as we'll hear about in a few minutes, used GIS as a foundation for carrying out the 2020 census. And this map in the upper left shows the census response rate predictions that were made in order for them to know where to knock on doors as opposed to do mail-outs. In the upper right, we also see their work showing the insured and uninsured rates by state. Well, lots of information has been analyzed here and visualized, but one of my favorite is done by the city of San Antonio, a kind of interactive equity atlas, which allows different government programs to be evaluated systematically against their racial equity implications. Let me also say a big shout out to all of you who worked on the COVID-19 response. We're still in the midst of this pandemic, and these examples show the sort of breadth and reach of what's happened. Literally thousands of organizations have used GIS to help them not only tell the stories of where the cases are moving, but also be able to do analysis. For example, the one in North Carolina where they're forecasting where infection rates will be going, but then overlaying it against hospital capacity, a fundamental spatial analysis activity. And today, with vaccine, we're seeing picking the right location for vaccine sites. What are the drive times? How do we do location allocation modeling? The great work being done by the National Guard in South Carolina shows this. It's amazing. And then, by the way, some of you used the patterns of COVID's movement to evaluate against different operations, like the Army Corps against their operations around the country. And also looking at the impact of COVID against firefighters. And also fundamental here has been the work done by the Census Bureau in planning out their activities in the context of COVID. Speaking about the Census Bureau, this year I'm privileged to be able to make the Making a Difference Award acknowledgement to the U.S. Census Bureau. This is an organization who is perhaps less known by many people, but also more known by many people. And every year, every decade, they count all of us. And this last year, they did an amazing job. Here, I'd like to introduce, to receive this award, Ron Jarman and Deirdre Bishop to receive the Making a Difference Award. Ron, Deirdre, would you like to say something?
Jack, we really want to thank you for recognizing the hard work of the folks at the Census Bureau in pulling off a successful 2020 census. So, you know, GIS tools and Esri tools in particular were critical for our preparations for the 2020 census, but maybe even more so in making adjustments during the census because, you know, we were doing the census during the COVID pandemic, during hurricane season. We had wildfires out west. So it was a very challenging time, and the use of GIS was really critical for having us be able to make those real game time adjustments in the census that allowed us to be successful. But, you know, it doesn't stop there. You know, we're using all GIS tools as a sort of central organizing premise around modernizing our programs to improve data products for our users and to get ready for the 2030 census. So one of the great initiatives that we're doing that Deirdre is actually leading, we call frames, and it sort of centralizes all of our survey frame information, and geography is the central organizing tenet of the whole thing. So we're really honored that you recognized our hard work this way, and we look to continue that success into the future. So Deirdre, do you want to add anything?
I'd love to. Thank you, Ron. Thank you, Jack, for selecting the Census Bureau as the recipient of this year's Making a Difference Award. I'm honored to be here with you to accept this award on behalf of everyone at the Census Bureau that worked hard to design, plan, research, test, and implement the 2020 census. Over the past few years, you invited us to tell our story on your conference stage, and we shared information about how this census incorporated the use of geographic information systems throughout its design, using the Census Bureau's Math Tiger system, our national database, and then tools provided by Esri, along with special applications. We use those tools to help establish where to count all the people, to motivate them to self-respond, to knock on their doors when they didn't, and now to tabulate all the people to the correct geographic location. We look forward to sharing the 2020 census results, and we're anxious to watch how this GIS community uses our information to help make informed decisions for our future. Thanks again.
Well, Ron and Deidre, you are two of my heroes, actually, in the federal government. And this Making a Difference Award, I really wish I could personally give it to you. It has special meaning, making a difference. And many of the users here listening make a difference. Their footprints are all over the federal government. But the work done by the Census Bureau, building this foundation information, not only addresses the mission of getting the census done in effective ways, a geographic way, but also the information, is a foundation for the other federal agencies. It makes a difference. It's also a foundation for state and local government, and it's also a foundation for business, commerce, and university research. Ladies and gentlemen, I just wish you were all together so that we could together acknowledge the great work of these two special people, but also this particularly special agency. I'd like to now move on to the theme of this year's conference, Interconnecting Our Nation. And this is an important theme. I'd like you to contemplate what it means for you as individual citizens, but also for you as agency participants in this mission. The vision here is interconnecting and creating understanding. This means interconnecting our people, our organizations, using GIS and geography to frame human activities, bring our information together, all the different ologies, and interconnect our technology, integrate and transform our future. Today, we're at a moment of history which is, as many people have said, unprecedented. Of course, they're talking a lot about COVID, but COVID is only one of the dimensions of crisis that we're facing. Loss of nature, loss of natural resources, resource shortages, social conflicts, congested cities, the emerging climate change. These are like waves of issues that particularly you listening are particularly involved in. Being able to address these issues, this uncertainty of our future, is going to require all of us getting together. It's going to require comprehensive approaches. So let me simply say overcoming the challenges, maybe that's a good way to frame it, requires fundamentally better understanding of our world. It requires better communication and collaboration to take our best science and technology and our best, most of all, our best problem-solving capabilities, which is where you and the GIS community really is essential. We need to build a kind of geospatial literacy in our nation that guides and directs everything that's done. And this starts with my favorite science, geography, the science of our world. It's all about providing a way to organize and integrate knowledge. It's also about helping us interconnect the different disciplines. I like to think of it as like overlaying maps. That's a way to bring it together. Geography provides that integrative nature. In GIS, the technology we work with, is a way to abstract geography, a kind of common language for organizing and applying the knowledge that we have. And it brings together virtually all types of content from every agency, from every discipline, from every background. And this is important. It's about connecting and modeling and visualizing our world like one globe. We'll hear tomorrow from a woman who has been to outer space. She has seen the whole world. This is Dr. Catherine Sullivan. She's seen it and she understands it holistically in her mind. And this, in many ways, is what we do with GIS, framing, providing a special lens to the world so that they can more intelligently act. Now, the way GIS does it is it organizes our geographic information into digital bits, we might say, or building blocks of shared information and understanding. The data, of course, but also data models that organize it thematically and so on. It frames it with analytic models to be able to predict and model what's going on. It's a language of visualization, maps and stories and the reports that are generated from it. And finally, it's a frame for organizing work management. These building blocks, actually, ladies and gentlemen, are the key to being able to provide a framework and a process where data and measurement information is visualized, analyzed, and then used in various settings to lay out strategies and plans to make better decisions and ultimately take them to action. GIS, for me, is about creating and applying geographic knowledge holistically and widely. And the work that you are doing is increasingly being recognized at the highest levels of government, not just in this country, but around the world. GIS professionals like yourselves are applying this science, the science of geography, in lots of little projects, in individual systems, in, I don't want to call them stovepipes, but often mission organizations organize it that way. But increasingly, this information that you're building, the knowledge that you're building, is being interconnected. It's being interconnected using web services and the ability to dynamically bring information together to represent this holistic view of the world. It's building, we might say, geospatial infrastructure. What is this geospatial infrastructure? Well, it's been described in different ways over the years, but it's now becoming very real. It's an architecture, actually. It's the modern GIS implementation pattern, where distributed information can be dynamically brought together and overlaid and integrated and support individuals and teams and departments and whole organizations and communities. It's leveraging the services-based nature of GIS today. And so I'm going to be hitting on this subject, geospatial infrastructure, again and again during this session. But I want you to simply realize this is not a vision any longer. It's the ability to bring knowledge together and share it and engage everybody in being able to use it with more holistic solutions. Geospatial infrastructure is emerging very rapidly, and it's interconnecting not just data, but also capabilities, analytics, real-time data, big data, special AI and machine learning models, so that the GIS professional opening their browser or their desktop can have access to a network of knowledge that helps them do their work better, helps them see and understand. Let's start with some of these building blocks. GIS is advancing. It used to be that we'd take all kinds of data and put it into one data bank, and then that would be shared for people to use. Today, I can connect to data of almost every format and type from distributed networks of servers and make them not only integratable through common portals, but also supporting a whole plethora of different kinds of application. Here, multi-dimension data, CAD data, BIM data, LiDAR data, tabular data, even unstructured data can be integrated, georeferenced, and then used. And this is not just the raw data, but also we are learning how to use GIS to create these things that are now being called digital twins, a kind of snapshot of everything that we see in reality. And these digital twins are emerging rapidly in the form of landscapes. And for specialized technologies like BIM models, we can now bring them into the GIS frame. We can model digital twins of networks and whole cities and see them, integrate them, and begin to analyze them and all of their characteristics together. GIS is taking off in ways that we had never really imagined before the web. Maps and dashboards are becoming pervasive. Take, for example, the dashboard of the coronavirus from Johns Hopkins. Actually, nearly 2 trillion map views have been made from this one site. And it's one example, but there are many others. Dashboards, story maps, web maps are opening the eyes so that we can see, tell stories as authors, but also help the world understand what the implications are of different human actions. Apps are similarly taking off and providing powerful capabilities. They're becoming pervasive in some ways. Web apps and also just massive mobile deployments, putting GIS inside, not only for collecting data, but also seeing views into this emerging geospatial infrastructure. And this is just the beginning, ladies and gentlemen. It's going to open access to your work everywhere for everyone. Advanced work happening in visualization and modeling and advanced analytics are also exciting to me. We figured out how to do volumetric GIS using voxel technology, real-time GIS, tracking everything that moves and changes, looking at the oceans, looking at the atmosphere, looking at living dynamic cities. We're able to capture information now almost like transactions from drones and bring them into GIS and do extensive modeling in almost every domain. Part of the secret here has been able to access and integrate dynamically the whole world of open science right into the GIS frame and make it part of the solutions that many of you are building. I'm particularly fond of this advancing activity, which is we're seeing that dynamic and 3D GISs are coming alive. They're taking transactional data, like 3D feature data that's updated based on, for example, new construction and so on, and integrate it with 3D meshes, reality capture, captured from drones and aircraft, bringing them all together. These transaction systems, the feature databases, I mean, all of you know what a system of record is. They're really 3D systems of record. So as new buildings are created, boom, I can update the database and everybody else sees views are up to date. This is very powerful for not only seeing in real time a digital twin, but also being able to plan and lay out scenarios for alternative futures for cities. And underlying this is new technology that allows us to do reality capture and bring in these 3D meshes and mix them up with vector information. This image of downtown Frankfurt shows these beautiful 3D pictures, 3D meshes, but they're mixed with vector information or thematic information. So we can see the whole, we can interact with the whole as if it's one model, but it's leveraging the vector data and all of the attributes about it, or the thematic data, with our 3D twin that was just created hours, for example, ago using drones or aircraft. All of this is becoming automated, and the GIS data model of reality is becoming richer and more productive. This is going to become pervasive also as a kind of way to do GIS. It's not just rasters and vectors, it's the whole. Specialized geospatial workflows are beginning to emerge, and specialized products that support them. For example, in urban planning with a technology known as Urban, and in emergency management with a technology known as Mission, and on and on. Other ones like indoor mapping and indoor navigation and analytics. I'll be talking about some of these more in just a few minutes. We're also seeing GIS become embedded in other major IT systems, systems like SAP or Salesforce or Microsoft systems or IBM systems. Wow, this means that your work, the work of building geospatial infrastructure, can be embedded and integrated into other sorts, completely other sorts of technologies and other kinds of transactions. And it's going to create a kind of revolution of insights and understanding. It's not just little maps inside your apps. No, it goes much further than that. And our collaboration with different major software vendors is helping us building direct integrated tools. Organizations are also increasingly collaborating, and we see this all over the world. In my neck of the woods, as they say out in California, one of the big utility companies, Pacific Gas and Electric, or PG&E, is now sharing their information with the state emergency management organization as services, so it can be integrated and overlaid, things like outages or facilities, and vice versa. We're seeing new collaboration in state and local agencies. And wonderful example is our own Census Bureau, where they've used services to work with state and local governments, sharing information, or sometimes referred to as sharing common services. This is a kind of revolution that's occurring. And similarly, we're seeing with the web, these new GIS hubs pattern, the next step beyond simple portals, transforming the way that we engage citizens and also the way we engage agency to agencies. This is interesting because it makes maps and apps a kind of language for interacting, for getting information from citizens and telling stories about the situation, doing collaborative planning, providing whole new ways to participate around common interests. Look, geospatial infrastructure, this pattern I've been describing, is literally transforming organizations. I have a great privilege of watching sort of from the front row much of the work that you are doing. You are transforming your organizations, leveraging and integrating lots of new tools, cloud computing, AI and machine learning, the use of apps to make it spread all over, the ability to integrate smart mapping and smart visualization. All of this is coming together, ladies and gentlemen, as we, as a collaborative community, continue evolving our work. This is becoming powerful. I mean, individual projects were interesting. When you began to build systems, that was even more interesting. Whole departments like Department of Interior or many others, Department of Agriculture, brought together subsystems that are beginning to build systems of systems, form coalition. That's been a gradual evolution. And along the way, it's helped you organize your work, improve communication, helped understand complexity, and also came up with a foundation for holistic solutions. And this is what is really needed to address these big issues that we're facing particularly at this time. Infrastructure, this idea of building collaborative infrastructure across the entire government is important. But realizing this kind of an interconnected nation, the thing I've been abstractly talking about, and addressing these big challenges is going to take more than just technology. I mean, I feel so intimidated by the challenge of it. Mere technology providers are not going to do it. And even the science behind our technology is not enough. It's going to take people like yourself who understand the problems of systemic racism, problems of climate change, problems of water contamination, and so on. Understanding it first. Understanding precedes action. And then collaborating and envisioning solutions to these. This is you say, well, I'm not in that business, I'm not in the solution. Yes, we are all in that business. It also requires organizing work, doing the real work. It isn't just waving your hands. No, it's like doing the time and the money and the allocate and organizing it. It finally requires much of what many of you do in public service, which is a sense of purpose. And so let me simply say the work of GIS professionals, your work, is critical, and your leadership is essential to be able to realize this kind of a vision. Well, let me pause for a moment and say I'd like to shift gears and now move on to sharing our work. This is the work that Esri does on your behalf. It's all about, for us, building useful tools and technology that helps you be successful, and we do that around this technology known as ArcGIS. ArcGIS is a single system. It's an integrated product vision that supports multiple communities, the GIS community, of course, but also the rapidly emerging mapping and location service community and location analytics, and also now expanding into integrating and supporting developers and big systems of all types. Finally, our work has been focused on leveraging ArcGIS to build what we call geo-enabled systems, which are standalone systems that support specific workflows. And we do this, of course, with software. That's been our heritage. And then later, SaaS. And then this year, with a new idea of providing platform as a service that is basically consumption-based services to the developer and large IT company and enterprise organizations. ArcGIS, as many of you know, is 3 separate systems in one: a system of record keeping, a system of analytics, and a system of engagement through maps and apps. And increasingly, this system has become real-time, integrating imagery and IoT information into the core. This system is implemented in a variety of patterns. Many of you are desktop users. Actually, we have millions of desktop users, and it's our biggest pattern. But the second pattern is enterprise systems. These are big servers that share information across the web or across networks to a whole plethora of different user types. The third pattern, which I've been spending a lot of time on speaking this morning, is this idea of a cloud-based geospatial infrastructure, which allows you to host information on servers and integrate it with SAS and PAS information. And finally, the last one, which is emerging really rapidly, is the idea of embedding these kinds of geographic knowledge infrastructure fed information into embedded apps for massive numbers of people to use. Esri's cloud strategy, many of you have asked about it, is about supporting three independent but also integrated offerings. Software in the cloud. For example, our software is increasingly based on Kubernetes, and you can release it in the cloud. This is really a whole new operating system that allows it to be cloud native. A second offering is SAS. That's really what ArcGIS Online is all about. And later this morning, I'll talk about PaaS. This is really platform or consumption-based services. I would like to especially call out this move to Kubernetes. This is not for everyone, but for people who wish to leverage microservices and really make their systems scale at very large size and leverage some of the new native storage capabilities of clouds and do distributed computing. Kubernetes is a platform for doing it. And this will open up and make available ArcGIS for deployment on virtually any cloud. I'll come back to that in just a minute. ArcGIS is integrating many new innovations in data measurement, new computing innovations like Kubernetes, but others like mobile distributed computing, ultra-high bandwidth like 5G. All of these things are being built into our system. And finally, the system is leveraging advances that we're making and others are making in science, opening up the platform so that it integrates open science technology of many types. I have shown a similar slide to this for many years. It's really making the point that ArcGIS is an open platform. And we achieve that openness through supporting aggressively, vigorously supporting open standards, but also providing an open architecture that is extendable, having open science integrated in, and some of our components are open sourced with a rich library of ability to evolve and work with us in that manner. This year, we've continued to make advances in new APIs and provide progressive technology for supporting the whole world of open data. Our fundamental capabilities, and by the way, a few hundred meters from where I'm standing, there's a large building complex of developers who are continuously advancing the fundamental capabilities of our software. These several thousand developers are advancing work in image processing and remote sensing and in real-time mapping and mapping itself in data management. And I'm going to cover a few of those, giving you just a few highlights of what the work is that's going on, because it affects you. And of course, during the course of this conference, we normally have lots of feedback, and we'll be doing that digitally. Not at the convention center this year, but in various ways. ArcGIS has, by design, inside of ArcGIS Online, included massive amounts of ready-to-use content. A lot of this content is your content, but it's been organized and put into forms as services. Thousands of layers of ready-to-use living atlas data, and then millions of data have been sets and maps and services and apps have been shared by you. So there's kind of this collaborative environment so that people that are hunting for data to use in their applications can just have quick access to it. This is global data as well as national information, and we keep making more improvements on it. In the innovation area, we keep progressively moving ahead with something we call smart mapping for web mapping. These allows mere mortals like me to make beautiful maps even though they don't have a cartographic experience by using machine learning tools that really encapsulate making beautiful maps for everybody. And these are implemented in our map viewer and also in the JavaScript API tools. In more traditional mapping, for example, desktop mapping, we continue to make some new improvements here. And some of you will be interested in specifically the work that we're doing there in adding new symbologies and being able to deal with new modern templates and being able to handle special cases like generalization or special graphics. And then also making advances in map and chart production with automated tools. Story maps have been, I guess you might say, a huge hit or very popular. There are actually now over 1 million of these that have been published, and tens of millions of views on these every day. They tell the stories of the world. They're easy to build and easy to publish, and they tell stories. Last year, we introduced a new storyteller role called, the storyteller role. And it is designed to be able to allow your colleagues in other parts of the organization who don't know GIS so well to be able to tell stories and use this amazing set of tools. I mentioned earlier that we have worked closely with a number of the large technology providers to provide embedding of our mapping tools, like into Microsoft's Office and Microsoft SharePoint tools and Power BI. This year, we're releasing a new capability to have our web maps inside of Teams to support the idea of knowledge workers doing collaboration around mapping. Also, the embedding of maps in Adobe and into Autodesk's interesting and significant products for engineering have really opened the way for us to provide geographic context for other tools. Our dashboards have been amazingly successful. In a few minutes or a few hours, being able to set up and give synoptic views, providing situation awareness of all kinds of information. And these dashboards, of course, can be embedded inside of story maps. So I can share a story map and provide real-time information on what's going on. Location analytics, specifically in the form of the product ArcGIS Insights, have opened up some of the capabilities of ArcGIS to sort of an intuitive, visual way to interact and do spatial analysis for business kinds of applications. That people can bring in just about any kind of data. They can visualize it. They can make cool maps. They can do exploratory spatial analysis and then generate reports and make them available. For those who wish to do more sophisticated spatial analysis, there are several thousand tools in ArcGIS. And in the last year, we've added a few hundred new ones in data engineering and advanced visualization and exploration. Some new spatial analysis tools, one of which is my favorite, which is a new, very simple way to do suitability mapping, bringing multiple layers together and map it. But lots of advances in machine learning and AI, and also being able to access and manipulate big data in the clouds. And this is just the beginning of an adventure, ladies and gentlemen. As we get bigger data sets, more and more of this will be done. Finally, in being able to do modeling and scripting using things like notebooks, more advances there. Jupyter notebooks are a big jump for us. They really were first introduced with ArcGIS Enterprise, but then we moved them last year to both Pro and also to ArcGIS Online. What this means is I can organize and automate certain kinds of processes and do modeling within the notebook frame. And it opens up the world of Python libraries, as well as other open source libraries, to bring right into my GIS technology. Speaking about AI and machine learning and deep learning, we have made some major progress here for allowing our users to have access to the open source and data science ecosystem through things like notebooks and also through integration with Python and R. And that's not just one, it's from Pro, it's from Enterprise, it's from Online. So I can literally take advantage of and bring in this huge and very rapidly and aggressively growing technology world into geoprocessing. Our goal here is really to make it easy for GIS users to be able to take advantage of all of this amazing automation and making GIS smarter capability. Look, in the last few years, we've also made major advances in bringing imagery and remote sensing right into the frame of GIS. Today, we would characterize ArcGIS as a comprehensive system supporting imagery data management, now going to the cloud, also mapping and data production, bringing in powerful tools like drone mapping and so on, being able to do some of the most sophisticated analytics, and also doing visualization and exploitation. This is really capturing information off of the imagery and putting it into vector databases or thematic data sets. This is a powerful platform that this year we're moving major pieces of to the cloud. It'll become an extension of ArcGIS Online, so I can upload my imagery and process it there. I'll show you a demo of this in a few minutes. To bring this capability together, last year we introduced a new technology called ArcGIS Caliber. And this allows a user to search through the large libraries of imagery, organize a project, like pulling the data sets together, and then do exploitation and analytics on this information. That is, drawing features on imagery, pulling knowledge from the imagery, and then being able to share it and disseminate it as web maps and story maps, etc. This is exciting because it's dynamic and it's connected and it's real-time imagery, near real-time coming in, and it's all powered by this idea of a server technology in the form of ArcGIS Enterprise. Drone mapping has been an interest for me personally, but also for our organization. Some years ago, we introduced a technology known as Drone to Map. This is for desktop users. They can fly their drone, load it down, bring the data down into their desktop, and then process it to make some interesting maps and do specialized kinds of analysis. This last year, we acquired a company that introduced us to taking the same kind of capabilities and doing it in the cloud. This is a technology known as site scan. So now I can fly my drone and send the content that it's captured over to the cloud, and it does the same kind of capabilities that Drone to Map does, except some new things as well. This is kind of sometimes I use the desktop version, sometimes I use the cloud version. When I put it in the cloud, then I can have access to it, of course, with the new emerging capabilities of imagery in the cloud, in our online, and so on. Anyway, these are exciting and progressive activities. I'm very pleased to announce a brand new capability for most of you, which is automated reality capture. This is done through a technology known as SURE, or now called SURE for ArcGIS. This takes imagery data, point cloud data, and of course the orientation data, and it processes it automatically at scale. We're talking like a whole city or massive amounts of imagery data, and creates outputs like true orthophotos or textured meshes, point clouds at scale, and digital surface models, all automatically. Those are all directly then usable inside of the rest of the ArcGIS system. This will transform mapping agencies and those who do mapping in a major way, automating, making fast, massively scalable products that can be used directly. I'm going to pause for just a minute and have Madeline show you a quick demonstration of this 3D reality technology.
Today we're going to explore how reality capture extends 3D GIS into new areas and across 3 different scales: city, building, and landscape. Let's get started in the city of Frankfurt, Germany. 2D data is readily available all over the world, providing context with information like building footprints, parks, and trees. We can see this data in our 2D vector base maps and world imagery. And even though it's very detailed, it's still not a true model of the real world. But with new processing technology, we're able to quickly build a 3D mesh of Frankfurt using Shore for ArcGIS, taking our visualization to the next level. This mesh was created from over 800 2D aerial images, collected by plane over the entire city. A completely new view emerges. Skyscrapers pop out, providing context, and zooming in, we can see details on roof forms and even construction sites. The mesh provides a new way to interact with the scene. Here, we can quickly measure the height of the building. With 3D GIS, a snapshot of reality is at our fingertips and gives us the opportunity to explore entire regions from afar. But this model is more than a mesh. It also gives us the ability to create 3D smart maps using classic GIS techniques. For example, using a point cloud to illustrate a thematic map of building elevation over the city. Here, the old historic heart of Frankfurt, with its more elaborate roof forms, lies in stark contrast to the modern high-rises of the financial district. More traditional GIS data can be added in as well. This analysis shows elementary school service areas for the city and the corresponding school, interacting just like a 2D map, but with the underlying element of reality. Let me show another example. In Los Angeles, just east of LAX, a new stadium finished construction in September. The area surrounding the construction site is largely flat and can be visualized with simple building extrusions. Following the stadium's construction, a low-altitude drone was used to capture imagery, which was then processed using SiteScan to create a high-resolution 3D mesh. Zooming in, we can see details of the new stadium, like this open space for public events, exposing the data collected by drone. We can enhance this model with an orthomosaic of the site, and one really valuable way we can start to use this mesh is for special event planning, ensuring community safety with large crowds. Using the special event planning solution, we can quickly create a plan with special event assets, road closures, and safety information, and overlay it on top of the site, giving an on-the-ground operational view to understand and contextualize the area for a large event. When we think of capturing 3D data, we typically think of our urban areas, but reality capture extends to our natural landscapes as well. In this topographic map, we can see the dramatic elevation of Mammoth Mountain. Let's enhance it with a hillshade derived from LiDAR, highlighting the bare terrain and steep slopes. Next, we'll add in an orthomosaic that was captured in the wintertime, so we can see the landscape covered in snow when it gets most of its use. And lastly, we'll add in 3D buildings and trees that are derived from LiDAR. And now we have a beautiful raw view of Mammoth, a realistic 3D model. Mammoth is known for its world-class recreational opportunities with skiing in the winter and hiking in the summer. Trail and slope data can be overlaid on top of the 3D model, fusing together different sources of GIS data. Here we can see the expansive trail network in orange and ski runs in black, blue, and green. The runs are rated by difficulty. And turning on the slope analysis, the difference in ratings becomes obvious. The steepest slopes are rated black for experts. The blue follows more moderate routes for intermediates, and green highlights the easiest routes for beginners. This 3D scene is a true fusion of different sources of data, from elevation data to points, lines, and polygons to analysis results. Now, so far, we've seen examples of 3D GIS over a city, building, and landscape. But let me show you one last example that fully integrates reality capture with GIS. This is a 3D mesh of Denver's Central Business District. At 2 centimeters resolution, we can see extraordinary detail, from street furniture to vegetation and even traffic infrastructure. The detail is exciting, but it's made even more powerful using underlying GIS attributes to make it completely interactive. Clicking in the scene identifies the object selected is a traffic light and tells me when it was installed and last inspected. I can easily identify the street, but clicking an inch over tells me the name of the light rail line that cuts through. This is 3D GIS and the ability to access the wealth of information behind the mesh. So when you're exploring and you want to know what this bear is, a simple click will give you all of that information and more. With 3D GIS, we're able to fuse together different sources of data to create a true view of the real world. Thank you.
Thank you, Madeline. That was just amazing. Now you can see, maybe better than me explaining it with PowerPoints, why I'm so enthusiastic about this integration of meshes and the automation of mesh creation. It's going to change our world, and literally at the global scale, all the way down to doing little projects. I'd like to move now on to looking at 3D GIS. Here we again have made a number of improvements and advances. First, in the 3D information model. And I have talked about this at some length with the idea of point clouds or 3D meshes being able to be stored at scale inside of ArcGIS. But last year we introduced a new model called voxels. This is really looking up into the sky and into the oceans and into the ground and being able to model and analyze voxel data. We've also integrated some of the smart mapping capabilities into 3D, so I can have the machine help me suggest the best cartographic representation in 3D. And then we've introduced some new symbology and visual effects. And in the lower right, I want you to look at these two capabilities, looking at augmented reality and virtual reality. Some of that's been going on for some time, like looking under the ground at the vector data of pipes. But the top is something probably new for most of you, which is the wrapping or the embedding of our APIs into game engines. This means the beautiful viz, sim, or visualization and simulation capabilities of game engines will be able to access your geographic data. This is going to be a lot of fun. Of course, some people will just make games, but others will use this as ways to present their information to a whole new audience and even improve how we do it visually ourselves. In addition to visualization, GIS has been advancing in 3D analytics using simple geometric analytics like viewshed and so forth, but increasingly accurate and at scale. And then volumetric analytics, this gets back to this voxel idea, being able to look into the oceans or look into the atmosphere and do change analysis or just exploration of these volumes in new ways. The way that we've done 3D GIS is not just with one app, it's actually 3D GIS for visualization and analytics across all of our systems in mobile and devices, in ArcGIS Earth, which is a specialized app for 3D visualization, in City Engine, in Pro, in the Scene Viewer, and in the Experience Builder, whose job it is to build unique and custom applications. In other words, it's pervasive. Similar in concept to 3D is what we might call 4D, real-time visualization analytics. And here we've been working for a number of years on technology called the Geo Event Server that takes real-time data, IoT data, and makes it available right within the frame of ArcGIS. And there are thousands of users who use this technology with server-based work. But last year we introduced a new ArcGIS Online extension called Velocity. And what this does is it allows you to connect your real-time IoT data, let's say buses moving around or water flowing, to a cloud environment, specifically the Azure cloud. And the data is read into this environment and then in that pipeline analyzed and visualized and supports the idea of big data analytics and support for all of our other tools. Rather than me talk about Velocity, I think I'm going to have one of our special people, Suzanne Foss, give a quick demonstration of it and explain it in context of a real application.
Thanks, Jack. It's increasingly important today for federal agencies to have awareness of the status of their facilities and understand what could impact operations. For example, this U.S. Postal Service facility is currently operating normally. These airport facilities are running at normal operating status, but they could be at risk soon due to severe weather in the area, like storms and lightning strikes. Down to the south, this Social Security Administration office is temporarily closed due to the pandemic. And many federal offices are supporting their missions today with staff that are increasingly working from home. And what makes working from home possible in times like a pandemic is connectivity. Real-time information on connectivity is increasingly available from different data providers. This includes things like voltage measurements from the electric grid, telecom network throughput information, and reported outages. This kind of information doesn't illuminate the external forces that could be contributing to these issues. For example, are these issues related to the weather systems that are moving around the area? Could traffic accidents or road work have caused damage? The question is how these diverse data streams can be consumed and leveraged together to understand the potential impacts. ArcGIS includes scalable, real-time, and big data analytics to help answer these kinds of questions. You can build automated services to ingest, transform, and analyze data, taking action along the way. Using ArcGIS Velocity, you can get started by creating a feed to consume real-time data. A feed enables you to connect ArcGIS directly to IoT systems, like cloud platforms and messaging brokers. You connect to the data stream, configure a data model, and publish a continuous cloud-hosted service that ingests data and lights up your maps with streaming information. But what's really exciting about this is that you can use real-time analytics to synthesize these different data streams, weather, traffic, threats, and use them with the data coming in on connectivity and outages. These scalable analytics enable you to detect incidents in real time or over time, even on large volumes of data. You can put together real-time and big data analytics in minutes without writing a single line of code. This analytic is automating a process to evaluate these external factors against the reported outages and connectivity issues based on proximity. Then, depending on the most likely culprit in each case, it's automating different kinds of output action, like identifying the closest field crew member that could be deployed to investigate. These analytics can run continuously on each message as it arrives, or run on a scheduled basis. This one's running every 5 minutes. Let's take a look at some of the results. The analytic has identified a couple outages that could be affecting federal facilities. In each of these cases, it's mining these different data streams for nearby events to determine which is the most likely to have an impact. So for example, in this area, there's a lightning strike about a mile away and some traffic incidents along the highway. But it's the traffic accident on a nearby local road that's most likely to have contributed to the issue. It's possible that a vehicle hit a telephone pole, caused the disruption of service to this part of the network, and this would then impact the USPS operations. Now, down by the Social Security office, there's a road closed for road work. So it's possible that a construction crew damaged a fiber line or a network device. And up here to the north, there's a lightning strike in the immediate vicinity of the outage. Now, depending on the most likely root cause in each of these cases, the analytic also automated different output actions. In some cases, like with flooding, the right output action might be to send an alert to all facility staff. In other cases, the analytic identified the closest staff member out in the field and sent a notification specifically to them. And this is showing where that staff member was at the time that they were alerted. As the nation integrates and connects more and more data sources, agencies can be even better prepared to identify threats around their facilities and personnel. The challenge is not just understanding where issues arise, but to rapidly fuse multiple sources of intelligence in real time to identify probable culprits. With scalable real-time and big data analytics, ArcGIS enables you to apply the power of location to understand what's happening around your assets and prioritize where to take action. Thank you.
That was amazing, Suzanne. Thank you very much. It's just sort of every time I see your work, it just gets me so excited because I realize we're moving into a real-time world with GIS. For some of you, data management and editing of data is foundational to the systems that you build. And here we're making advancements in being able to support leading systems and platforms in the cloud and also on-prem. We're improving the geodatabase and also improving editing tools both in 2D and in 3D environments. Closely associated with data management is field operations, especially the data collected in the field. And here we have a number of data collection and capture, inspection and survey tools like Survey 123 and Collector, which are pervasively used. But these are part of a system. Part of a system that allows you to plan and manage your work, and then a dashboard that shows progress of field workers as they're doing the work. And then there are aids like navigation aids, and in the field, visualization aids like the map exploration capabilities of Explorer. And then more recently, location tracking, the ability to know where the workers are in times of emergency. This is really critical. Okay, the last thing I want to mention here is in the last year, we released field maps. This brings together capabilities of collector and tracking and exploration all together in one app. This is something that you've asked us to do and will empower a more simplified experience in the field. I'd like to now again shift gears and talk about ArcGIS products. And here you'll notice right away ArcGIS 21 products. This is a new nomenclature that we're embracing, like some of our colleagues in other IT organizations, rather than this version and that version of this pro and that. No, we're going to have one name, the ArcGIS 2021 fleet of products. And actually the way our products work is that it's licensed in individual components, but it is one comprehensive and integrated system with Pro for the desktop, with Enterprise for server capabilities, with Online for SaaS. And this last year, we've introduced a new PaaS capability for opening up the platform that underpins all of the other tools for developers. We think that this will create a surge in the ability to create apps and solutions that live on top of all of the rest of the products. I'm going to start by explaining what we've been doing with Pro. Pro is a professional GIS technology for advanced mapping and visualization. It's used by most of you here in the audience. It's used for editing and analytics and data management. Well, we've made lots of improvements here. Just for the record, we have now accomplished this feat of replicating virtually everything that is done in ArcMap, and then much, much more, including a whole services-oriented capability. And we keep this march of advancing capabilities here for authoring, analyzing, and using spatial information. Lots of new things coming. Pro is extended with a number of focused capabilities. These are in the world of analytics, and also in the world of data management, and also in the area of out-of-the-box production, mapping, and charting. The second big leg of the stool is ArcGIS Enterprise. And while ArcGIS Desktop has millions of users, ArcGIS Enterprise also has maybe hundreds of millions. We don't actually know, but we certainly know that there are hundreds of thousands of deployments of the server. And this is rich because it brings it all together as a server platform, being able to do data management and mapping and content discovery. The portal is supported from here, being able to do spatial analytics on the server side and sharing and collaboration. And then, of course, the strong administrative DevOps foundation. Here, we have a number of extensions as well in the form of image server and notebook server, geo event server, and so on. One that I'll call your attention to is the ArcGIS Monitor, which for the people in charge of running the DevOps, this is a kind of a miracle technology. Helps them understand and monitor what's going on. And then there's lots of new capabilities that have been added in the last year. But this spring, in a few months, we will release ArcGIS Enterprise on Kubernetes. I've already spoken quite a bit about this, but it's not only allowing us to deploy on Kubernetes in a way similar to the way you deploy on Windows or on Linux, but also it will introduce more standards-based, IT standard-based integration capabilities. It'll mean easier maintenance, easier upgrades, easier dynamic scalability capabilities. So for some of you, not all of you, this might be a major solution in your future. ArcGIS Online is the third leg of this technology, and it's the world's largest mapping and data sharing ecosystem in the geospatial world. It actually has now over 10 million users who use it just thousands of times, hundreds of thousands of times every day. It now contains over 39 million data sets and items and apps that have been shared by our users. So it's absolutely a sharing services platform, and trillions of maps are being made from it every year. This last year, it's grown enormously in usage, over 400%, and lots of new things coming here. ArcGIS Online has extensions as well, just like the other two products. One of them is Hub, the ability to do citizen engagement and other kinds of engagement activities. This year, we're releasing Velocity, the technology Suzanne just showed, as an extension of online for all of our users. And also, I'm very pleased to announce that we'll be implementing something called Image, which is an extension that allows our users to be able to host imagery in the cloud and be able to use it in analytics and visualization, and also do some interesting spatial analytics with it. Actually, rather than me talk about this last extension, I've asked Yoon to be able to share a quick demonstration of what you can do with it. So Yoon, why don't you take it away?
Many organizations in the federal government have the need to share image services between agencies and the public. This can occur during daily business operations as well as in times of emergencies. The new ArcGIS Image for ArcGIS Online Beta provides hosted imagery capabilities along with visualization and raster analytics in the cloud. Last year, approximately 10,000 fires burned more than 4.3 million acres in California. To understand the impact and severity, we'll analyze the area near Santa Rosa using the new ArcGIS Image for ArcGIS Online. For our analysis, we'll be using a collection of satellite images that cover this area. These images that I currently have locally can now be hosted directly to ArcGIS Online. Let me show you how. Images can be hosted as static tiled image layers or dynamic imagery layers that support dynamic mosaicing and on-the-fly server-side processing. From the interface, users can select the layer configuration, choose the data type, and fill in additional information such as the processing template and more. By simply dragging and dropping the image files and their metadata, and filling out the item description, these image layers will now be hosted in ArcGIS Online. Fast forwarding a few minutes, once the data is uploaded, we can add it to our map and begin our analysis. This is an image near Santa Rosa after the fire. By changing the band combination on the fly, we can now have a better look at the impacted area, indicating loss of vegetation in orange. We'll continue our analysis by applying a raster function template, which will classify the area by burn severity. The raster function editor in ArcGIS Online provides 153 raster functions out of the box that can be changed to create a complex model. These raster function templates can be shared and used across desktop, enterprise, and now even on ArcGIS Online. Once the template is loaded, all you have to do is click on Run Analysis to get your results. In the interest of time, I have it generated in advance over 3,000 square miles. The high burn severity is shown in orange and lesser severities in other colors. Now, one of the questions that you might ask next is how many structures were in the path of the fire? And if you didn't have the building footprints previously mapped, we can leverage the deep learning capabilities in ArcGIS Online to extract the building footprints. To get started, let's go to the new raster analysis tools, select deep learning, and in our case, detect objects using deep learning. Using high-resolution worldview imagery provided by Maxar, and going to the Living Atlas, we can select from a library of ready-to-use deep learning packages that include land cover classification, road extraction, human settlement detection, and more. For our use, we'll select building footprint extraction. Let's take a look at the results. The model was able to extract tens of thousands of building footprints in just a matter of minutes. We were able to determine the number of buildings within the burn perimeter. This was just one example of using ArcGIS Online with hosted imagery. Now let's take a look at a different topic and at a national scale, conservation. The 30 by 30 initiative is about preserving 30% of our lands and oceans by the year 2030 to balance the physical, biological, and cultural assets of our environment for a sustainable future. Here are the areas already protected within the US. Roughly 12% of the lands and 23% of the oceans correspond to an assigned GAP status 1 and 2, which requires permanent protection of its natural state. Overlaying managed federal lands, we can see a broader area covered, color-coded by managing agency. In order to achieve our conservation goals and reach 30%, we may want to identify areas of the federal land suitable for additional protection, and new areas across the US with a high priority in our conservation efforts. To answer the question where to focus our efforts, we collected available resources on the Living Atlas to build a national inventory of information layers which will help us define the characteristics across the US. The first example dataset is NLCD, Natural Land Cover Dataset, created by multiple federal agencies using different variables like vegetation type, agricultural use, and development density. The next dataset, created by conservation scientist David Theobald, shows human modification across the US. The darker the red, the larger the human influence on the area. The third example shows biodiversity importance generated by NatureServe. The brightest colors indicate where multiple imperial species occur and are currently not safeguarded. These are just 3 examples of the information that we loaded into ArcGIS Image for ArcGIS Online to create a collection of 27 layers describing the land characteristics across the US. Using raster analytics, we created the first national map of minimally disturbed natural areas, also known as green infrastructure. This layer is not just a visual description of the location, but also an information-rich data set that allows us to perform analytics and help us answer where to prioritize our conservation efforts. Conservation priorities are not always the same for everyone, and as a result, it requires input from multiple stakeholders. This web application allows us to leverage the benefits of the dynamic imagery layer and help us narrow down potential conservation areas based on different scenarios. Let's assume that we would like to expand the conservation areas around Yellowstone National Park. Looking at the federal lands, the immediate vicinity is managed by the Forest Service, so we'll prioritize forests and biodiversity for this scenario. The result of this analysis is a weighted overlay, highlighting areas of high conservation priorities in dark green. Now let's take a look at a different scenario, prioritizing wetlands instead of forests. We can change the weights and get an alternative answer. Let's try one more, wildlife conservation corridors. When we start to look at this from a larger context, we can discover the natural network forming pathways across the US, like this one that connects from the Grand Teton to the Upper Green River Valley and south into Colorado, which happens to be the largest pronghorn migration corridor in Northern America. As most of this corridor falls around BLM lands, this analysis shows possible areas for additional federal conservation and protection. These were just 2 examples of ArcGIS Image for ArcGIS Online providing managing, hosting, visualization, analytics, and sharing capabilities at any scale, conveniently and efficiently in a software-as-a-service environment. Thank you.
Thank you, Yoon. I get so excited at seeing your demonstrations, not only hosting imagery, but also exploiting it. And then there's all of these rich image-like capabilities for raster analytics at scale. One of my favorite applications is the green infrastructure applications, which I think will set a kind of tone for us to be able to do these amazing initiatives of protecting 30% of our natural environment by 2030, one of the president's initiatives. The other extension that I'll mention is ArcGIS Hub. This is also becoming extremely popular, not only in state and local governments, but across the federal government. This allows you to stand up a site that allows open data to be able to be shared frictionlessly. With many of you, this is an important initiative. It also allows you to support special initiatives that engage citizens or engage each other. It allows you to organize communities. It allows you to provide a license for community users so that citizens can actually become engaged with your work. This, I think, is dramatically improving extending the reach and the ability to communicate with the public participating in your GIS operations. Quietly in the background, ArcGIS solutions also are playing a major role in our users' success. These are literally hundreds of industry-specific maps and apps that are made available freely so that you can configure, they're pre-configured tools and models and data models and add-ins that extend the fundamental capabilities of ArcGIS. And they're organized into these various domains. I invite all of you to look at these because they are free. They're supported just like the rest of our technology, but they help you very quickly deliver value. This last year, we saw it happen with the COVID templates of maps and analytic capabilities. They just went viral around the world. For those of you who wish to build your own apps, Esri supports a series of app builders. These enable everyone to quickly build apps using widgets. The web app builder has been the most popular of these app builders, and there are over 1 million apps that have been built and deployed around the world. We have been systematically building a new generation of the web app builder. We call it the Experience Builder. And this is new technology. It allows us to focus on mobile optimized apps and also take advantage of the powerful new 2D and 3D capabilities that are being brought into the system. Now, for some of you, you wish to develop and deploy native apps, that is cross-platform native apps, and we have a powerful technology called App Studio to do so. Now, heretofore, the business models of how we license this were sort of set up friction for normal users to do it, but that has been taken away. So I wish you to examine very carefully this capability if you wish to have pervasive device apps that you can connect people around the community with. For those of our community who wish to build even more serious and sophisticated apps, we have something called ArcGIS Developer, which provides extensive capabilities for building various kinds of applications, customizing our platform and extending it in various ways. These include various APIs and SDKs, and they fall into 5 big categories. The most important one that you could look at is the Python API for developing scripting, and this is the world within which Jupyter Notebooks lives. The second one is extensions to Pro with Pro add-ons using the Pro SDK. And the third is the technology I was just referring to, runtimes that allow you to build mobile and native apps and deploy them extensively. We are working on the capability to leverage these runtimes with game engines. That'll be happening later this year, and for some of you, it'll be very exciting. The fourth one, and perhaps the most extensively deployed, is the JavaScript APIs, which are pieces of code that live inside of a browser that talk to the powerful REST APIs in our server and online capability. Finally, this year, we have released a series of new open source APIs that talk to our powerful REST API in the server environment. These are APIs that support open layers, leaflets, and more. And they allow very quickly people to embed this capability right into their third-party clients. All 5 of these dimensions bring powerful spatial capabilities into virtually every domain, every kind of developer. The JavaScript API, which I mentioned is one of the most popular, has literally dozens and dozens of powerful, high-performance web app capabilities that you can very quickly configure and customize inside of your environment. And you can use things like the web app builder or the new experience builder to be able to build the apps that are fed by this. This new capability for open source supported developer tools is back-ended by a new technology for platform as a service. We refer to it as the ArcGIS platform. Actually, the ArcGIS platform underpins all of our other technologies like Pro, like our enterprise server, and like ArcGIS Online. We've just never exposed it through open APIs in the past. So we are offering new ways to access our platform as PaaS. And that means capacity or consumption-based usage rather than subscription-based usage. It's a distinction. So these capabilities of mapping, geocoding, routing, access to all of the rich data layers of the living atlas and so on, as well as a whole plethora of spatial analysis tools are being made available to developers and also for embedding in large enterprise system deployments. I'd like to finalize this discussion with a few comments about Esri's geo-enabled systems. This is not core GIS or even applications of core GIS. They are standalone, focused workflow systems which access the content of geographic information systems, but they are standalone or are synergistic with our other technologies, and they fall into 5 big families. The GeoPlanner is for landscape planning. There's one for urban, there's one for business analysis, there's one for indoor navigation and mapping. And finally, there's a new one for mission-focused applications called Mission. I pulled out a couple of these for more detailed explanation. Given the challenges of massive landscape planning requirements, this capability is a data-driven design capability. My original field, landscape planning, so I could sketch out alternative designs and then quickly visualize them and analyze their impacts, one versus the other, and then share them with the masses. This is not for everyone, but it certainly responds to those who wish to do conservation and natural resource planning. A second one is indoors. It's sort of the opposite end of the scale. It's all about modeling buildings and being able to have a fleet of applications for doing space management and visualization and facility management and supporting a way to experience the building digitally from devices like navigate through, find the right room, or find the right building on campus. A third one is mission, and as I mentioned, this is a brand new one. It's for planning a mission like a fire or an emergency response to some event, execute and manage that from a management perspective, and then from a field perspective, understand what's going on, supporting peer-to-peer communication among the various responders in the field, and then after an event, be able to analyze and do forensics of the event and understand what went wrong or what went right. This is tying together a lot of little pieces of emergency management response, and it's now organized in a kind of tactical situation awareness and collaboration technology. Well, where are we going next? I've shared with you what we did last year and some of the research agenda that's going on in 2021. This is a list of capabilities, and by the way, these are the ones that we have planned based on interacting with you in the past. But if there are other ones that you feel like we should focus on, please use this occasion, but also later, to be able to tell us the areas of innovation that you'd like to have us work on. It's a lot of work, but we have several thousand people in our development departments working on it, working really on behalf of you, advancing the methods, advancing the tools, but also looking after quality and performance capabilities. Well, I'll conclude with a few remarks about Esri. We are alive and healthy and well. We are continuing to grow, are financially strong. We continue to advance our big mission of serving you, and at the same time, advance GIS and the science of our world. We have adopted a whole philosophy of wanting to build strong engineering tools, strong science-based engineering tools, and then working in collaboration with you to make a difference on some of these big challenges. This is why engaging with you in the right way, such as this kind of meeting, is so very important. So I want to just take a moment and say thank you for the opportunity to do our work. Thank you for the opportunity to engage with you in all these various programs. It's very meaningful for us. It's enormously motivating, as I'm sure you would understand. In addition to software, and I've talked a lot about that, we also have a number of activities at Esri to support your own professional development, and they include publications and blogs and websites and technical support work. They also include the idea of progressive learning programs, and we have a number of these, from MOOCs to learned lessons to web courses and instructor-led courses. This idea is that we promote the idea of continuous learning, and there are literally hundreds of free courses that you can take. This is a time to do it when some of you are at home, and we encourage this idea because it's really through the new learning that we advance the overall mission and capability. In addition to our own resources, Esri leverages and has built a huge partner ecosystem. These are some of the key sponsors that are focused around this particular conference, but also ones that we work with very closely. Some of them are huge, technology companies, and others are small startups that are building applications around our core system. And they, like us, are committed to your success. And I think that's a healthy way to look at our ecosystem, you and me, and these other kinds of companies. Esri also is very interested in education, and we support two programs. One is for higher ed programs of education like colleges and universities, and have licensed our tools in various ways to departments and more recently to students. And then there's the K through 12 program. Many of you have children and you know the power of what this really delivers. It's bringing STEM, geographic STEM-like education into that environment with literally hundreds of thousands of kids learning GIS, learning geography using GIS as a platform. And one of our major partners is the National Geographic Society, who are helping us build curriculum and being able to address this market more effectively. I also want to invite you to be geo-mentors to schools, to teachers, to help students everywhere acquire this kind of spatial literacy. And I think it's just fundamental for our future, growing the next generation of spatially literate society. Esri is also very active in the mission of conservation, and we have many thousands of partners who have licensed freely our software to be able to help us work on this. And some of these are global, huge organizations like the Nature Conservancy and Audubon, and others are small little watershed groups that are in both the developed world and undeveloped world that are pushing this mission of using geographic knowledge to better understand and protect nature. Well, ladies and gentlemen, thank you again for the opportunity to come here and be with us. I'd like to conclude with a few departing thoughts. One is GIS and geographic science are evolving rapidly. In my entire life, I've never seen it move so rapidly. And they're becoming now a new kind of pattern, this geospatial infrastructure pattern. And this is helping individuals who access this infrastructure. It's helping organizations, and it's also helping communities come together and do their work better and more collaboratively. This new government set of policies that are emerging call for better science and collaboration. They really sing music to many of your ears. They will deal with tackling some of our toughest questions, and geography and GIS are going to become essential for being able to address these problems. These are going to open many opportunities for you, opening opportunities to achieve in your own domains, but also opening opportunities to bring things together in more effective ways, supporting data-driven decision-making in more effective ways, and finally, just being able to become a powerful force that creates and applies geographic knowledge everywhere and addresses our biggest challenges. This is important. It's also going to be about interconnecting our government so that it works more effectively. And this is up and front and personal to all of you. I really wish you the best in this next year of continuing to evolve the kind of systems and applications that you're doing. And I want to say thank you again for coming to this. I deeply appreciate it. And we're going to have a wonderful time in the next couple of days exploring your work, our work, and growing together. Thank you.